the amazing Joe Franchetti, as you can tell. And this is the first time you've ever done this one in person, right?
Yeah.
And the second time ever, or more?
I've only done it once before, and that was a remote one.
Yes, so cool. So, let's give a huge a round of applause. Yeah. Woo!
Hello, everybody. I realize we're slightly out of season for this, but happy belated Halloween, I suppose. I hope you're all having a frightfully fantastic conference today. My name is Joe Franchetti, and I am a developer advocate at Ably. And Ably is a serverless WebSockets platform that allows you to build all kinds of fun, real-time experiences into your apps. And so to mark the end of my favorite season, the spooky season, I thought we would maybe use WebSockets and build a real-time experience and build our very own online tool to commune with the spirits of the dead, a Ouija board. And you might hear it called a spirit board. The trademark is Ouija board. It's a flat board which is marked with a bunch of numbers, all the characters of the alphabet, and the words yes, no, and goodbye, along with a few symbols and graphics. And it uses a little heart-shaped piece of wood called a planchet, which moves around the board as an indicator of what the spirits from beyond are trying to say to us. And participants place one finger each on the planchet, and then it is moved around the board to spell out words or to give messages. And spiritualists believe that the dead are able to contact us through the messages that are spelt out by the Ouija board. If you're not a spiritualist, you might think that maybe what is actually happening here is something called the ideomotor phenomenon, which is where everybody has just very infinitesimal movements, and if you have multiple people with their finger on a planchet and they're all infinitesimally moving it, it might end up moving around the board. But the idea is that by posing questions, the participants kind of subconsciously spell out the answer that they're looking for, which, one could argue could be the spirits from beyond trying to commune through us. So, if the spirit board can make users involuntarily, that's how you pronounce that, move their hands around a physical space, can we reproduce this effect in a computer with a mouse or perhaps with your device? In principle, the effect should work exactly the same way. Players have a natural desire to move in a certain direction, and we can take those sort of infinitesimal movements of a mouse or a device and collect those movements together, average them, and then move a planchet around the board. So why not build it? Curiosity never got anybody in trouble before. So let's have a go. So we're going to build an app, and the app is going to have to do a few things. Firstly, it's going to have to measure the gyro movements from our devices or movements from our mice. It's going to then animate the planchet around the board. Whenever the planchet crosses over a letter, a number, or a word, it's going to need to reveal that to us. And then it also is going to, is going to reveal the character to us. So what is the app composed of? Well, we're going to make a progressive web app. It's going to have some plain old JavaScript, HTML, CSS, and some SVG. It's going to do some collision detection, so we're going to need to know when the planchet crosses over certain paths of the SVG. We're just going to use the browser APIs to do this. And then we're going to use WebSockets, which are going to let us communicate between everybody's different browsers when they're using the app. And finally, we're going to add some spooky sounds in as well. So this is the application topology. The entry to the app is index.js. We've got some really, really basic HTML in the HTML file. It's literally just an H1 and then an SVG, which is going to be the board itself. We've got a manifest because it's a web app so that we can hide the browser Chrome if we want to. And we've got an offline HTML, which is going to be displayed if you're offline. And all that says is, please go online for this to work. We need to be online for WebSockets to work. And then we also have, what else have we got? We've got our assets, which is just the images and the CSS. We have our audio, which is our spooky sounds. We have this networking, which I will talk about later, which is how we're going to communicate between the different browsers. And then we have the TypeScript itself, which is making the app functional in spiritboard.ts. So let's start with spiritboard and write some functionality, which is going to actually capture the mouse movement and the gyroscope. So first we're going to create a spiritboard class, which we're going to instantiate in our index.ts file. And inside it, we're going to put the logic which makes the board work. So first of all, we're going to pass it the ID of the HTML element that we're going to actually put the spiritboard into. So there we go. Okay, that's our HTML element. And then we're going to create a function called enable gyroscope. And this is our enable gyroscope function. We're also going to set up a listener for mouse move. So we're going to support both mouse and gyroscope, as I mentioned before. So let's flesh out that gyroscope function now. So first of all, we're going to check whether or not the gyroscope is available. You know, if you're on a desktop computer, you're not going to have a gyroscope. So in that case, we just return. And then we're going to add an event listener that is going to listen at a frequency of 60 times a second. And we're going to listen for that actual movement. You'll notice there's a magic multiplier here, which is times 10, and that is because gyroscopic movements are a lot smaller than mouse movements, so I'm just kind of multiplying it by a random number just to make it a little bit bigger, so that our mouse movements and our gyro movements are similar-ish. And for now, we're just going to log the values that we're interested in. So we're logging event movement X and event movement Y for the mouse. And for our gyroscope, we're logging our effective X and our effective Y, which is the 10 times multiplied numbers that we get from the gyroscope. But we don't really want to just console log these. We want to be able to send them between browsers. And the way that we are going to do that, as I mentioned, is with WebSockets. The way that we do communication between browsers normally is with WebSockets. It's a really cool protocol that allows us to do real-time communication. So what we do is we're opening a connection between all the different browsers, and we can send packets across that connection as they happen in real time. The connection stays open, so unlike HTTP polling, we don't have to keep saying, has somebody moved a mouse? Have they moved a mouse now? Have they moved a mouse now? We can just send that data as soon as the mouse movement happens. And I'm using Ably to do this. We could be using vanilla WebSockets, but Ably has a whole load of really nice APIs that sit on top of vanilla WebSockets that I personally find make it easier to use. And the lovely thing about the Ably product is that it allows you to scale, so we could potentially have millions of users all using this Ouija board all at once, which is much more difficult with vanilla WebSockets. Before we dive into the actual networking, a brief introduction to how we're going to use WebSockets. So we use something called a pub/sub pattern, which is going to help us send the messages between the machines. Pub/sub stands for publish and subscribe, and we use an idea of channels to send data out on. So we have a message broker, which manages the channel. Data is sent out on that channel, so that is our publish, when we send data out on that channel. And then all the different browsers can subscribe to that channel, and they will receive that information. In our case, I'm going to create one channel per board, so different spiritualist groups can have different boards happening at the same time. So we'll create one channel per board, and every user of the board is going to subscribe to that channel, and every user of the board is also going to be able to publish data out on that channel with the delta X and Y coordinates that we looked at earlier. So we're going to make a networking function that uses ably to send data between the browsers. And as you can see here, what we're doing is we're sending a message which is called nudge. And we're just sending an object which contains the delta X and the delta Y. So let's take a look now at how that networking actually works. So if we take it back to absolute basics for a moment, if we wanted to send a message, just any old text message with ably, we would do it like this. So we make a new instance of the ably library, we pass it an API key, and then we create a new channel, which in this case we're going to call movement. So movement is the name of our channel. We're then able to publish data to that channel. So here we have published a message called nudge with the movement data that we had. And we can also subscribe to that channel and find out what that movement is as well. If we sent a message for every single mouse movement and every single gyro movement, we would be sending millions of messages. I don't know if you've ever console logged mouse movement, but there's a lot of them, which wouldn't be very efficient. So what we're going to do is we're going to batch them up and send them out in a buffer. So with our networking class, we're going to capture all of those ably interactions. That networking class exposes a function called send buffered message. Go on, animation, hooray, there we go. And whenever we send a message using this send buffered message, what it actually does is it puts the message into a variable called outbound buffer. And if during the sending of the message, the buffer reaches the buffer cap, which we've set at 150, you can see at the top there, then it'll flush the buffer. And flushing the buffer simply takes that whole collection of messages that we had and sends them all out in one message all at once. To make sure that all of these messages are sent, so maybe we don't hit 150, there's also a timer which is going to send after, what have we got? 1 second. So every second the buffer is going to attempt to flush itself. Any messages that are left unsent are going to get sent out, which will hopefully help us sort of meter out the messages that we're sending and prevent any huge spikes in our traffic. If one user's got their mouse and they're just going like this with it. So elsewhere in this class, we've got if a bulk message is received, then each of the array elements is going to be looped over, and our message handlers are called for each individual item. And then back in index.ts, we're going to register some message handlers which are going to respond to these messages when they're received. And they're going to get processed by our networking class. So we have a way to measure the movements of the mouse, to send them between computers. Now we need a way to actually put something on the board and move it around. So let's talk about what the board is first. So I made this beautiful SVG graphic, and then underneath that is another SVG, which is just a bunch of very basic paths. And the SVG is made up of shapes called polygons that mask out the area contained by each letter, and this is what we're going to use for our collision detection later. The reason for doing this rather than just using the outline of the letters is because I'm sure you will notice some of the letters have empty holes in the middle of them. So I want the planchette to read out, for example, the letter O when it goes over the O, also when it hits the middle of the O. So that's just going to stop that from happening. The markup of the SVG looks like this. So we have repeated polygon shapes. Each of them has been given some attributes. So we've got a data item, which tells me what character it is. The data focus, which tells me the coordinates of the center of that polygon. I have a class for styling and for running detection on. And then the points actually are the outline of the path itself. And so now we have a bunch of information that we can get when we do the collision detection. The planchette itself is just an image in a div. It's absolutely positioned. It's got a transition on it, which will make it smoothly change its position around the page. You'll also notice that it's relatively sized. So if you're on a small browser, you get a small planchette. If you're on a big browser, you get a bigger planchette. There's a lot of maths involved in this thing. So to make the planchette move, first we are going to create a class for the planchette with render, move, and center methods. So render is going to set the CSS translate on the planchette to move it to the correct place. Move is going to move it to the correct place. Render is going to place it into the board. Move is what is going to update the X and Y position of the planchette to move it around the board based on what data we sent in the messages earlier. And then the center method, every time we cross a boundary with a letter, it's kind of nice if the planchette really shows that letter in the center. So we're adding the center method, which will move the center of the circle of the planchette around the letter so it frames it nicely, which is just a nicer user experience for our spiritualists. So in the spirit board class then, we're going to add methods to move and render the planchette. Render is going to call render on the planchette, and it uses a request animation frame, which queues a callback to itself. If you've not used it before, request animation frame is a browser API for animating page elements, and your browser calls this function many, many times a second to match the frame rate of the browser that you have. This frame rate normally matches the refresh rate of your display. And this means that we're going to be constantly running this render function, which is going to mean that the position of the planchette is updated constantly. So that X and Y position is going to be updated very regularly. Then we've got that nice CSS transform, which is just going to make the movement slide around the board. Then we're going to add some handlers into index.ts, which is going to manage what happens when we send and receive messages. So when we receive a message called nudge, we're going to get that X and Y and set them as translate values on the planchette, and the planchette is going to move. So the next thing we need to do is hook up the collision detection. So how do we detect when we've crossed a boundary? So for example, here, the planchette is revealing the letter S. So how do we know that that is happening? The first thing we need to do is calculate where the planchette's viewfinder is. So that's this point here, which is at 50% of the width and 33% of the height, because I made it that way. And what we're going to do is we're going to find out the X and Y coordinates of the top left point of the planchette, and then we're going to add 50% width and 33% height to that. Then we can use this cool API called detect elements at point, which detects what elements are at that location. So it returns a collection of elements that are at that exact point. So we've got the top left of the planchette. We've got the top left, we're moving along 50, down 33. Is there any elements at this point that have the class of the path that we were interested in? If there is, what was the letter that was associated with that? If we do find that we have a letter associated with it, then we can call this reveal function, which is going to do the centering of the planchette on that space. So as soon as we cross a boundary into a letter, after a couple of seconds, so it feels intentional, we're going to center the planchette on that letter, and we get that really nice user experience. You know, the spirits are really talking to us now. So if we remember back to our SVG, we had a bunch of interesting metadata on those SVG elements. This is what the SVG look like, so we can get the data item, the data focus, as I already mentioned. So if we want to actually reveal the items, we're going to need to do a couple of checks to see if the item that we want to reveal is the one, if we've crossed an item that we want to reveal. We're going to temporarily block mouse movement because otherwise we just keep zooming around the board. So if we cross into an item, we briefly stop and then we do that centering reveal. The final thing to do is to add a nice spooky animation in. So every time we do, now that we know that we've revealed a certain character, say the letter S, what I wanted to do was have the letter S float out of the page at you so that it's really been revealed. So let's have a look at how we do that. So each element is just a div on the page. So what we can do is we can, we've already got that letter from the SVG, so we know the data character that it was. We can set the inner HTML of this div that we've put on the page to be that character. And then we're going to add an animate class onto it. And this is the CSS that does this nice animation. So we are zooming, so we're making the character from small to big. We're putting a little bit of a wobble on it so it sort of floats out of the page. And we're putting an opacity on it so it fades out as it comes towards you. So it kind of looks like, I don't know, letters and smoke. Don't write your CSS like this. I've fitted it onto a slide. Don't write your CSS all in one line. Nobody likes that. So yeah, let's put it all together. So our index.ts file looks like this. So when a user joins, we will move the planchette to the center of the board. So they'll start with the planchette in the center. Then as soon as they start to move the mouse or they start to receive mouse movements from other players, we're going to move the planchette around the board. And if the planchette movement is outside of the board, we do a little bit of maths to just move it back in. We don't want the planchette to be able to move wildly off the board if every single user is swiping or tilting to the left. So we want to keep the planchette inside the board. That's more fun maths. I will share the repo later so you can have a look at all of the fun maths. But that is it. It is time to commune with the spirits. So I invite you to join me as we try and contact the ghost in the machine. You can follow this link here, or you can use this QR code. Once you've joined this serverless seance, I ask you to hold your device in both hands and place your hand on your mouse. Open your third I++. Clear your mind of the noise and thoughts of the day, and instead bring your focus onto the deprecated HTML tag that you mourn the most. As we ask, oh, apparitions of the pseudo-afterlife, shadows in the DOM, undefined objects of the underworld, what messages have you for us today? So let's see if I can join you. Oh, lucky number 7. Really wants us to know the number 7 today, I think. 7 again. I hope you've all bought your lottery tickets for this week. I mean, Z looks kind of like a 7. We're definitely getting some sort of message here. And sadly, you can't hear my spooky sounds. So a friend of mine very kindly recorded some sounds for me of himself whispering all the letters and the numbers of the alphabet. So it should say something like, sad. If you turn the volumes up on your own devices, you may well be able to hear that. Okay, so back to the real world. Can we... So if you do want to make your own spirit board, or you're just interested in using mouse and gyro movements for something far more sensible, all of the code is available to you here, github.com/ oh, that's actually incorrect. It should be ably/labs/Ouija. It's all open source. Please take it, make it your own. I would love to see what you make with it. And you may well be asking yourself at this point, why did I just listen to all of that, Joe? And yes, it is a very silly demo and not a particularly useful demo, but... Thanks, Dylan. Especially during the pandemic, a lot of people have been creating these kind of real-time collaborative environments where we're doing things like cursor sharing, we're doing things like collaborative editing of documents, and this is the exact kind of thing that you're going to need to build that. You could build multiplayer games, you could build chat apps, that kind of thing. WebSockets are really useful for any kind of real-time experience you can imagine. Anything that shares data between browsers. So I hope this has been useful and fun and spooky, and that you consider building something with it. Or just, have a good spooky time with the spirit board at your own leisure. Either way, thank you for listening, HalfStack. Happy belated Halloween. And I've been Joe Franchetti.
Your summoning of the spirits for us. I want to hear it again.
You want to hear the summoning of the spirits again? Okay.
Yes,
Okay. Place your hands on your mice. Hold your device in both hands. Open your third eye ++. Clear your mind of the noise and thoughts of the day. Instead, bring your focus onto the deprecated HTML tags that you miss the most. As we ask, oh, pseudo-elements of the afterlife, shadows in the DOM, undefined objects of the underworld, what messages have you for us today?
Thank you. It's so poetic.